Hello everyone, this is part 1 video on NEEt 2020 solutions for the physics. We'll start with the first question. A series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, means what they are saying is inductor is removed. The phase difference between the current and voltage is becoming pi by 3. If instead C is removed from the circuit, the phase difference is again pi by 3. So if you remove L separately, the phase difference is coming pi by 3. If you remove C separately, the phase difference is coming pi by 3. The power factor of the circuit is, now look at this now. If you have a series LCR circuit with an AC power source, we have an AC power source, there is a series inductor, capacitor and resistor. This is a series LCR. Okay, so let us say the inductance value is L, capacitance is C and resistance is R. Now when you remove, so we'll look at the first condition. When we remove L, what will be remaining in the circuit? Only the capacitor and resistor. So when you remove L means this is like a CR circuit in series. Okay, so CR means if you look at the phasor diagram, so what will be the corresponding phasor diagram? So the phasor diagram will be, we take the current and voltage across the resistance will be in the same phase. But what about the story of the capacitor? For capacitor, voltage will be lagging behind the current. So the voltage across capacitor will be like this, isn't it? So remember the mnemonic. What is the mnemonic? I hope you guys are able to look at some of the mnemonics. The common mnemonic is Eli the Iceman. So for the inductor, E represents what? EMF. So EMF will be coming ahead or leading the current. For the capacitor, current will be coming ahead of EMF, means current will be ahead of the voltage. Okay, so here for the capacitor, right, current series means both of them will have the same current. Resistance and capacitor, they both will have the same current, isn't it? So voltage across the capacitor will be lagging. Okay, so this is the phasor representation for what is the phasor representation for the CR combination. Now when we look at the given information, what they are saying, the phase difference between the current and voltage is what? Pi by 3. So how do we understand the phase difference? The overall voltage, right, in this combination, the overall voltage will be given by what? We will take it as the resultant voltage, isn't it? So how the resultant voltage is going to be? It will be the voltage across the resistance and voltage across capacitor. Resultant will be somewhere along this direction. Okay, so this is the phase difference, pi by 3. Okay, now when we look at in terms of the relation, so this is VC, so tan pi by 3 will be equal to what? Opposite, which is VC, by base or adjacent, which is VR. Okay, so which means look at it, what we'll have is VC, right, will be equal to I into XC. XC is what? The capacitive reactance. VR is equal to what? I into R. So IA is cancelled, and tan pi by 3 is what? Root 3. So root 3 is equal to XC by R. In other words, XC is equal to what? Root 3 times of R. So let us keep this as say equation 1. So I'll write it down here. What is it? What is the relation we have? XC is equal to root 3 times of R. Okay, now we look at the next situation, case 2. What is the case 2 situation? Here in case 2, we are removing the capacitor. So if you remove the capacitor, what is going to happen? The circuit is now going to become like what? LR combination, series LR combination, because you remove the capacitor, we'll have what? Series LR combination, correct? Now in series LR combination, what will be the so if you remove the capacitor means it is like series LR combination. So what will be the phasor diagram? Again, if you take the current to be along the x-axis, the voltage across the resistor will be in the same phase. But what about the voltage across the inductor? Voltage across inductor, right? See, inductor voltage will be leading the current, means voltage will be by how much? It will be leading by pi by 2. Okay, so in case of capacitor, voltage will be lagging behind the current by pi by 2. In case of inductor, voltage will be leading the current by pi by 2. Okay, so now look at it here. The overall voltage will be the resultant of these two. So look at this. This is our VL. Again, this angle is what is the phase difference. So again, what we'll have, tan pi by 3 will be equal to what? VL by VR, opposite by base. So VL is what? I into XL. XL is what? Inductive reactance. VR is what? I into R. So I is cancelled. So tan pi by 3 is how much again? Root 3. So root 3 is equal to XL by R, which means we will get again the value of XL is also equal to what? Root 3 times of R. So from the given conditions, right, we have got what is the value of XL and what is the value of XC. XC is root 3R, XL is also root 3R. Okay. Now we have to talk about what is the power factor of that original circuit. That is what they are asking. So what is the power for a series LCR, right? For a series LCR, what is the power factor formula? For a series LCR, the power factor formula is what? Power factor is given by tan phi, which is equal to what? Which will be equal to R by Z. What is R? The resistance value, and Z is the impedance. R by root of, what is Z? R square plus XL minus XC the square. But XL value is XC, right? Means XL minus XC will be 0. So what is there inside the root now? R square. Root of R square is what? R. So what we'll have, tan phi, which is the power factor, will be equal to what? R by R, which is equal to 1. Clear? So what is the power factor value going to be? It will be equal to what? 1. So from the given two cases, we are able to get the value of XC and XL in terms of the resistance. Okay, so they didn't give us what is the resistance value. We just took the value as what? Some R. The only information that is given us is that, you know, the phase difference will become pi by 3 when L is removed, and phase difference will become pi by 3 when C is removed. That is the only given information. So from those two cases, we are able to find what is the value of XL and XC in terms of R, and using the power factor formula for a series LCR combination. Power factor formula is what? Tan phi, which is equal to R by Z. So R by Z will be what? Since XL is equal to XC, this is also, by the way, when a series LCR XL is equal to XC, what does it mean? It is the condition of the resonance, isn't it? So the impedance, overall impedance value will be equal to just resistance alone. So thereby we will get the power factor to be equal to 1. Okay. We'll move on to the next question. This is a rather straightforward question on the formula. Okay. On the formula of the Hooke's law relation. Okay. So what is it? A wire of length L and area of cross section A is hanging from a fixed support. Means, think about it. We have a fixed support from where we are hanging a wire. Okay. So we have to think of it like a wire. Okay. So the wire is having a cross section area of A, and what is the length of the wire? It is L. Okay. The length of the wire changes to L1 when a mass M is suspended from its free end. So think about it. What they are saying, we are suspending a mass M from the free end of the wire, and as a result of it, what is happening? The wire is extending up to what? It is extending so that the final length is becoming equal to what? L1. So the final length of the wire is what? L1. We have to find what is the expression for the Young's modulus. What do we need to find? We have to find what is the expression for the Young's modulus. Now think about it. We are attaching a mass. As a result of it, what is going to happen? There will be a force acting on this wire, and that is basically the force that is trying to cause elongation in the wire. What will be the force? It will be mass of the, basically the weight of that object that is hanged, which is mass times acceleration due to gravity. So this is basically the force that is trying to cause elongation in the wire. And we have the wire, we are applying a force to cause the elongation. So the stress that is developed inside the wire as a result of this will be given by what? Because if you are applying a force to elongate the wire, since the wire is, or the rope or wire is considered massless, right? at each and every point the tension force inside the wire will be equal to what? Same as the mg. Each and every point the tension inside the wire will be same as what? Mg. So the stress will be given by what? Stress will be given by the force inside the wire, which is F divided by the area of cross section A. Okay, so force divided by the area of cross section. So what is the F value? F is equal to what? M into G, right? Divided by area of cross section is A. So this is the stress, and we have to look at what is the strain. Strain will be equal to what? Change in length by original length. What will be the strain? Strain will be equal to change in length by original length. So change in length means what? Final length minus initial length, correct? Change in length will be final length minus initial length. Final length is what? L1. Initial length is what? L. So look at it. So the change in length will be L1 minus L divided by original length is what? L. Okay. So what we'll have is strain. Strain will be equal to what? Change in length L1 minus L divided by original length is L. This is the strain value. And what is the Hooke's law? If we apply the Hooke's law, what is the Hooke's law statement? Stress will be equal to modulus of elasticity. Since we are dealing with the longitudinal stress and longitudinal strain, we will call the modulus of elasticity as what? Young's modulus. Stress is equal to Young's modulus into strain. Okay, so this is the relation we have. So Young's modulus will be equal to what? Stress by strain. So look at it. Stress is mg by A divided by strain is what? L1 minus L by L. So the A will come to the denominator, the L will go to the numerator. So what is it? mg into L by A into L1 minus L. So look at it. What is the correct answer for this? It is option 3. mg into L by A into L1 minus L. So what are we doing here? Just writing down what is the stress and what is the strain formula, and using the Hooke's law expression. What is it? Stress is equal to the modulus of elasticity into strain. Because it is a longitudinal case, the modulus of elasticity will be called as what? The Young's modulus. Okay. Next we have a straightforward formula based question on the solenoid. A long solenoid of 50 centimeter length having 100 turns carries a current of 2.5 amperes. The magnetic field at the center of the solenoid is, okay, so if you consider the solenoid to be a long solenoid, so you have a solenoid, if you consider the solenoid to be a long solenoid, right, what is the magnetic field at the center of the solenoid? It will be mu naught into small n into I, correct? What is small n? Number of turns per unit length. Small n is what? Number of turns per unit length. So it's a straight formula question. So look at it. At the center of the solenoid, what is the magnetic field? Mu naught into n into I. Okay, because they have not mentioned anything, we assume inside the solenoid the medium is what? Air or vacuum. Okay. Now small n is what? Number of turns per unit length. We have total number of turns 100. Length is what? 50 centimeter. 50 centimeter means in terms of meter, what is it? 50 in 10 power minus 2 meter. So number of turns per unit length will be what? 100 divided by 15 10 power minus 2. So totally what is it? 200 turns per meter. I is what? 2.5 amperes. And what is the SI unit of mu naught? 4 pi into 10 power minus 7. Okay. So we'll just have to substitute. B is equal to what? Mu naught, which is 4 pi in 10 power minus 7 into small n, number of turns per unit length, into I. So what is it? We'll just have to do the simplification part of it. So pi we will take it as what? So here we can see 2.5 into 4, it will become what? 10. Okay. So pi we will take it as 3.14. So what we will be having is 3.14 into 10 power minus 7 into 200 into 10. So look at this. This 200 into 10 is what? 2000. So if you take it as 2 into 10 power 3 means 10 power minus 7 into 10 power 3 is what? 10 power minus 4. 2 into 3.14, 6.28 into 10 power minus 4. Everything is taken in the SI unit, right? So the V value will be coming in what? Tesla. So what is the correct answer for this? 6.28 into 10 power minus 4 Tesla. Look at this. Option 4 is the right answer. Next we will go to another interesting question. It's a very standard question based on the prism. Okay. A ray is incident at an angle of incidence I on one surface of a small angle prism. Okay. with the angle of the prism A. See, small angle prism, we use this when we are deriving the minimum deviation condition, isn't it? When we are deriving the minimum deviation condition, we will use this small angle prism. Okay, small angle prism means what? The angle of the prism. So if you look at prism, right, the angle of the prism, which is basically the angle that you measure here, will be small. Okay, so whenever we have angle small, right, what will be the, the simplification that we'll generally do if the angle value is small, wherever we have sine theta, sine of that particular angle, we can say that sine of the particular angle will be approximately equal to the angle itself, isn't it? So that is the approximation we will do when we talk about the small angles. A ray is incident at an angle of incidence I on one surface of the small angle prism, and this angle is given by what? A, by the way, and emerges normally from the opposite surface. How is it emerging? It is emerging normally. So look at it. This is the second surface. Imagine it is emerging normally. Yeah, it is emerging normally means to this surface it should have come normally also, because normally emerging means what? Here the angle of refraction is what? 0, because when it is normally emerging means it is coming along normal. So what is the angle it makes with normal? 0, right? So the angle of refraction is 0 means angle of incidence also must be 0. So normally emerging means it should be incident on the surface too also normally. Okay, this point we should be clear. So this ray is basically coming from the refraction that it has had from the surface 1. So surface 1, this is the angle of incidence. So here we are incidenting the ray on the surface 1, it is getting refracted. Then at the surface 2, it is incidenting normally and also emerging normally. Okay, so generally when we talk about the prism case, right, I hope we will be able to recall some of these values. So here the angle of refraction, initially we will call it as what? R1. What is the angle of refraction? We will call it as what? R1. And here the angle that is incident, we will be calling it as what? R2. The angle that is incident, we will call it as what? R2. And the angle made by the emergent ray with the normal, we will call it as what? Angle of emergence E. By the way, what we have is R2 is equal to 0. Same is the case with E also. R2 is 0, E is also 0. And we have one more relation. What is it? The value of R1 plus R2 is equal to A. The angle here and angle here, the refraction angle here and the incident angle on the surface 2. R1 plus R2 will be equal to what? A. Here no, we are not able to show R2 and E because both R2 is 0, E is also 0. Okay. Now R2 is 0 means what? R1 will be simply coming as what? A. The value of R1 will be simply coming as A. So look at it. What are the things we have? When the light ray is emerging normally from the second surface means what? The angle of emergence is 0. Angle of emergence is 0 means the corresponding incidence also will be 0. So E is 0 means R2 is also 0. But what we have? R1 plus R2 is equal to A, angle of the prism. So R1 is equal to what? A. Now what we will do is R1 is A. We have to find the value of I, isn't it? We have to find what? The angle of incidence. So look at the surface 1. No, at the surface 1 we can apply the Snell's law. I is the incidence, R1 is basically the angle of refraction. Now look at it. If you try to apply the Snell's law, right, what is it? The refractive index in the air side, which is 1 into the angle of incidence is what? I. 1 into sin I is equal to what? The refractive index in the present side is what? Mu. That is what they are giving. The material is having a refractive index of mu. Mu into what is the angle of refraction here? R1. So 1 into sin I is equal to mu into sin R1. And what we see is 1 into sin I is what? Sin I only is equal to mu into what is R1 value? R1 is equal to A. Already we got it. Okay. Now here, since the angle of the prism is small, because we said small angular prism, sine of that angle, right, can be approximated to what? The angle itself, which means the mu into sin A value, right, will be approximately equal to what? Mu into A itself. Similarly, look at it. No, we are saying sin I is equal to mu into A. If A is small, then we are multiplying this with a factor mu. Definitely the sin A value also will be small only, it will not be large. because what will be the usual refractive index values? Say 1.33, 1.5, 1.4, like that only, no. So the sin A value also will be very small. So there also we can approximate it to what? The angle. So if you do it, what you are going to get? We will approximate sin I to I and sin A to A. So what we will get? I is equal to mu times of A. So what is the correct answer for this? Option 2. What are we doing here? First, the regular prism result, right? So we have angle of incidence I. First angle of refraction is what? R1. On the second surface, the angle of incidence will be R2. Final angle of emergence will be what? E. That is the notation that we generally follow. We have to go with same notation so that any problem, right, we will be able to just recall those formulae easily. And in this case, since angle of emergence is 0, R2 also must be 0, which means using the relation R1 plus R2 is equal to A, we are not deriving it, by the way. We will actually do the derivation in the when we are discussing about the angular prism. Okay, but here since R1 plus R2 is equal to A, that result we are using straight away. So R2 0 means R1 will be A. Now we are going for the Snell's law application in the first surface, and using the small angle simplification, right, we are able to get the value of I to be equal to what? I is coming as what? Approximately mu into A. Next we have a question which is again theoretical, based on the relation between electric potential and field. So what is this question based on? Electric potential and electric field. So what is this? In a certain region of space with volume 0.2 meter cube, the electric potential is found to be 5 volt throughout. Means everywhere the electric potential is what? Constant. Everywhere it is 5 volt. The magnitude of electric field in this region is, see, we can just straight away answer this by giving an explanation, or we can do it mathematically also. Think about it, right? If the electric potential is same everywhere, so throughout electric potential is what? Constant. Okay, now remember, in any direction we want to find what is the electric field component. In any direction you want to find electric field component. Okay, so what will be the electric field component value in the direction? Minus delta V by delta R, isn't it? Means you move a distance of delta R in that particular direction and see what is the corresponding change in voltage, delta V. So minus delta V by delta R will give us what is the electric field component in that particular direction. Okay, if you are looking at a small change, instead of using delta, what we will use? We will use D. Instead of using the symbol delta, we will be using what? D. But if you are considering that everywhere the potential is same, which means what? Any direction you consider, you will not have delta V at all. Always delta V will be what? 0 only. Means any direction you consider, what will be the electric field component going to come? Electric field component value is going to come as what? 0, which means there will be no electric field in the entire region when the electric potential is what? Constant. Otherwise, we also have a mathematical relation. What is it? The electric field in a region will be equal to minus dou V by dou X into I cap minus dou V by dou Y into J cap minus dou V by dou Z into K cap. What is this dou? These are partial derivatives. Partial derivative means what? Normal derivative. If you are taking a derivative with respect to X, we will consider. So we got our answer. By the way, we got our answer. What is it? The electric field must be 0. That we are able to get from the theoretical discussion. But we can do it mathematically also. Look at it. So what is the electric field formula from the potential? E bar will be equal to what? Minus dou V by dou X into I cap minus dou V by dou Y into J cap minus dou V by dou Z into K cap. What is this dou means? Look at it. No. If you have voltage is equal to, I am just giving one expression, x square yz like this. This is not related to the problem. I am just taking one example. If we are doing dv by dx, imagine, then this is nothing but what? Derivative of x square into y into z. If you take a derivative means we have to apply this product rule. X is a variable, y is a variable, z is a variable, like that. We have to apply the product rule. Okay. But when it comes to the partial derivative, if you are saying dou v by dou x, in this, right, when you take a derivative with respect to x, y and z will be taken as constants. So y and z will come as it is out. What is the derivative of x square? 2x, like that. So partial derivative meaning when we take a derivative of a particular quantity with respect to x, y and z are considered to be constants. It means we are trying to understand the change in the voltage value only because of change of the x. Similarly, dou v by dou y means what? Change in the voltage value only because of the change in the y coordinate, like that. So voltage is a constant, right? Voltage is what? 5 volt is a constant. If you do derivative with respect to a constant, we take a derivative means what? 0. What about dou v by dou y? Constant, 0. What about dou v by dou z? Derivative of the constant, 0. Always 0, right? Which means this is 0, this is 0, this is 0. What you are going to get? Overall, our electric field vector is going to come as what? 0. Okay, so we can answer the question straight away theoretically. That is the reason why, right? In a metallic conductor, okay, so inside the conductor, what will be the electric potential? Electric potential will be same throughout. That is the reason why electric field will be what? 0. Same. If you have a charged, think about it, if you have a charged spherical shell, not a sphere, you have a charged spherical shell. If you have a charged spherical shell, right? Now charged spherical shell, potential everywhere inside that shell will be what? Constant. Potential everywhere inside the shell will be what? Constant. And that is the reason why inside the shell, what will be the electric field? 0. Okay. So all these are some of the scenarios we can look at. Okay. So even if you remember these results, right, that inside the charged shell, electric field is 0. We will be able to easily answer this question because we know that throughout that region, electric potential will be constant. Hence, the electric field will be what? 0. Okay. So the answer for this is what? Option 4. Next, we have a theoretical question on the Bohr's model. This is from the atoms chapter. For which one of the following Bohr's model is not valid? Now, what are the species given to us? Singly ionized helium atom means helium plus. See, for which species the Bohr's model is valid? Bohr's model considers the interaction of the nucleus with the electron. That is it. When we do the Bohr's model derivations, right, we will only consider the electron and the nucleus interactions. We will not consider any electron to electron interactions in the Bohr's model derivations, right? We will not consider any electron to electron interactions. Means what? The whole model is defined for what? Single electron species. The entire Bohr's model is defined for what? Single electron species. So this is a very standard question. Okay. So singly ionized helium means what? Helium. What is the atomic number of helium? 2. Means normally helium atom will have 2 electrons, but helium plus means 1 electron. It is single electron. Deuteron atom. Deuteron is what? It is an isotope of hydrogen. Okay. So it also will have what? 1 electron. Singly ionized neon atom. See, neon atom has got 10 electrons, right? Singly ionized means it will have 9 electrons. Okay. This will have 9 electrons. It will not be having 1 electron. What about hydrogen atom? Yes, 1 electron only. So which of them we will not be able to apply the Bohr's model? It is singly ionized neon. Why? Because it is not single electron species. Bohr's model is valid for what? Single electron species. Okay. We will go into the question number 7. This is another straightforward question. Light with energy flux. So look at it. Energy flux is given by what unit? It is the power per area. It is in terms of what? The intensity. This is also what we call as intensity. Okay, so what is the energy flux? 20 watt per centimeter square. Falls on a non-reflecting surface, means what? Absorbing surface. At a normal incidence having surface area of 20 centimeter square. Look at it. Okay, so what is happening? We have an area. So what is the area? Area is what? 20 centimeter square. On this we are having the light with that given energy flux falling. The energy received by the surface during a span of 1 minute means what? In 1 minute, what is the energy received by the surface? That is what we need to answer. So look at it. How do you find out what is the energy received? What is the energy received? It will be the flux multiplied by the area multiplied by the time. That's it. This is what is the energy received, because flux will be what? Energy per unit area per time. Power per area means what? Energy per unit area per time, multiplied by the given area multiplied by the time. That's it. Here we have to be careful about the units only. So look at it. 20 watt per centimeter square into what is the area here? 20 centimeter square. So the centimeter square will be cancelled. And since we have to give the energy in joule, we must have the time in seconds, because time is given in minute. So minute is what? 60 seconds. Look at it. So what is 20 into 20? 400 into 60. Okay. Watt into second is what? Joule. So it is what? 24 into 10 power 3 joules. So what is the correct answer for this? Option 2. It's a straight question. All we are doing is what? The energy flux multiplied by the, it is falling normal to the area. So if it is making an angle means, then we would have taken the component. See, we have to be careful here. So the thing about this question is normal incidence, means the flux is falling normal to the area. That is the reason why it is simply flux into area. Otherwise we will have taken a component. Otherwise we would have taken a, so for example, if the area is like this and the flux is making an angle, imagine, then we will take what is the component. What is the component along the normal to the plane? We have to take what is the component of the flux along the normal to plane. Okay, so component will be generally given by what? The flux times cos theta value. Component is generally given by what? Flux times cos theta, isn't it? So what is the answer for this? Option 2 is the answer. Next we'll go to question number 8. It's a straight question on the formula de Broglie wavelength. So de Broglie wavelength of the charged species. An electron is accelerated from rest through a potential difference of V volt. They are not telling the what is the value of V. If the de Broglie wavelength of the electron is 1.227 in 10 power minus 2 nanometer, the potential difference is, see, generally when you have a charged particle, right, a charged particle which is accelerated through a particular potential, a charged particle accelerated through a potential, right, then the kinetic energy gained by the charged particle will be Q times of V. In this case, what is the charged particle? Electron. So E times of V. V is the potential through which it is accelerated. Okay. Now de Broglie wavelength formula is what? Lambda is equal to h by mv. We have alternative formulas. H by root 2mk. Momentum can be written as what? Root of 2 into mass times the k. K value is what? Kinetic energy. So what is the kinetic energy value? E into V. So h by root 2m ev. So this is what is the de Broglie wavelength formula for an accelerated electron through a potential difference of how much? V. Now the thing is, if we have the charge of the electron, what is the charge of electron? 1.6 into 10 power minus 19 coulombs. We know what is the mass of electron. What is the mass of electron? 9.1 10 power minus 31 kg. Okay, so we know the charge of electron, we know the mass of the electron. When we substitute these values, right, and h also is known to us. What is the h value? 6.626 into 10 power minus 34 joule into second in terms of the SI unit value. What we would be getting is, we will get a simplified formula that will be just having the de Broglie wavelength in terms of the voltage. Upon substituting the values, right, this formula, even we remember, what is it? After substituting all the values, we will get lambda to be equal to what? 12.27 divided by root V. This will be in terms of the angstroms. What is the value? 12.27 into, so 12.27 divided by root V in terms of angstroms. Now here, the value of the de Broglie wavelength is given as what? 1.227 into 10 power minus 2 nanometer. So what is a nanometer means? 10 power minus 9 meter. So 1.227 into 10 power minus 11 meters it will come. 10 power minus 2 into 10 power minus 11. Now it is 10 power minus 11 it will come. So substitute the values. So we are looking for the voltage, right? So we will take it to the other side. So root V will be equal to 12.27. Angstrom means what? 10 power minus 10 meter. Divided by lambda value is what? 1.227 10 power minus 11. So look at this. What we are going to get? Here 10 power minus 11. So we'll have a 10 in the numerator. 12.27 by 1.227 means what? That is also 10. So 10 into 10 is what? 10 square. So root V is 10 square. We square on both sides means V will be coming as what? 10 power 4. So once we have this formula, right, if we don't remember the formula means, then we will have to do it the normal way. Like, you know, we remember the base formula, right? What is it? Lambda is equal to h by root 2m EV. So from this formula we have to do. If you remember this derived result means we will be able to easily get the answer. Okay, that is the reason why when you are practicing, right, your professors or lecturers keep saying that you remember these standard results, which will help you in solving the questions fast. So what is it? We get root v is equal to 10 square. We remember this formula means it is very straightforward, right? In fact, I took some time to explain to you guys how that formula is coming. But if you already done that in your regular classes or preparation time means, you will be able to straight away go for the formula. So root v is 10 square means what? V will be 10 power 4 volt. So what is the correct answer for this? Option 3 will be the right answer. Next, this is a question on the change in the acceleration due to gravity. So what is the question? It's a question based on change in the acceleration due to gravity value. A body weighs 72 newtons on the surface of the earth. See, what is the weight of any body if a body is having a mass m? If g0 is the acceleration due to gravity on surface of earth, then what will be the weight of the body? The weight of the body on the planet earth is what? M into g0. What is the gravitational force on it? Means they are asking weight only, because weight is nothing but gravitational force at a height equal to half the radius of the earth. Remember, we have g at a height h formula. What is the g at a height h formula? It will be g0 divided by 1 plus h by r the whole square. Okay, so sometimes we'll also write it as what? G0 into 1 plus h by r whole power minus 2. Now the thing is, there is one more simplified result, that is g0 into 1 minus 2h by r. This way we will use when the value of h is very small in comparison to r. But look at this question, at a height which is equal to half the radius of the earth. This we cannot use here, we have to use this one. What is it? G at a height h is equal to what? G0 into 1 plus h by r whole square. Now what will be the weight at that particular point? M into g at the height. Correct. So we need to find what is the gravitational force acting on it at that particular height. In other words, we have to find what is the weight of that body at that particular height. So look at this. What is the weight formula? M into g at that height h. G at that height h is what? G0 by 1 plus h by r the whole square. Okay. So now what we are going to do? Straight away substitute. So this is what? mg0 is what? 72 newtons. And what is h value? H is equal to r by 2. They are saying, right, height is what? Half the radius of the earth. So just substitute it. So r and r will be cancelled. What is it? This is the denominator. 1 plus half is what? 3 by 2. What is 1 plus half? 3 by 2. Okay, so 3 by 2 whole square will come. Whole square means what? 9 by 4. The 4 will go to the numerator. So 4 by 9 into 72. 9 ones are 9 eights are. What is 4 eights are? 32. So the gravitational force acting on that object at a height which is half the radius of the earth. What is the gravitational force? It is 32 newtons. So in the previous years also we have seen questions. The change in acceleration due to gravity at a height at a depth. This is a very standard question that we will expect from the gravitation chapter. Okay. Next we have another theoretical question. Which of the following graphs represent the variation of resistivity with temperature for copper? What is copper? It is a conductor or metal. Now there is a fundamental difference between the metals and semiconductors. For metals, resistivity will increase with temperature. For semiconductors, resistivity will decrease with temperature. We know the reason also, because in semiconductors, right, the number density of the free charges will actually increase in case of the semiconductors with temperature. Okay, that will outweigh the reduction in the relaxation time. Okay, so there are two factors, right, that will be determining the resistivity. What are the two factors? One is the number density and second is the relaxation time. So in case of the metals like copper, what happens is number density will not change with temperature, that will be almost constant. Only what happens is the relaxation time tau will be decreasing. Relaxation time means what? The time between successive collisions. You increase temperature means what? The electrons will start moving with more randomness, more velocity or speed. As a result, the time between successive collisions will be decreasing. Okay, so with increasing temperature, the relaxation time or the time between successive collisions will be what? Decreasing. Okay, that happens both for the metals as well as semiconductors. But in case of semiconductors, the number density of the free charges will be increasing. That will be dominating also. Okay, So what we have is we have to conclude which of the graphs will represent. Now the thing is, when we talk about the resistivity variation with temperature, normally what we say is that rho is equal to rho naught into 1 plus alpha delta T. Like that we will try to indicate the change of the rho with respect to temperature. But here alpha is called as the temperature quotient of resistivity. Alpha will generally take it as a constant. But if you consider a long range of temperature, right, the alpha also will not be a constant. The alpha also will not be a constant. It also will change. So over a long temperature range, what we'll see, because when we look at this relation, right, we feel that this is a linear relation, that resistivity is increasing linearly with respect to temperature. But that is only seen when we have a very small temperature difference being observed. Over a long temperature range, right, what we will see is that resistivity will increase with temperature, but not in a linear manner. It will be increasing in a non-linear manner. Okay, so what is the graph that shows increase of the resistivity in non-linear manner here? Option 2. So for the metals, resistivity increases with temperature. Okay, but over a small range of temperature, we might see that it is having a sort of a linear relation. Rho is equal to rho naught into 1 plus alpha delta T. Like that we will represent the temperature effect on the resistivity value. But if you look at a long range of temperature, right, what we will see is that it will not be a linear relation, it will be a non-linear relation. Okay, so what is the correct answer for this? It is option 2. Next we have another theoretical question. So in this NEEt 2020 paper we have a lot of theoretical questions. Okay, so light of frequency, this is based on the photoelectric emission. Light of frequency 1 point times the threshold frequency is incident on a photosensitive material. So let us say, for example, the threshold, what is it? The threshold frequency value is nu naught. Like that we will say. Initially, what are we having? Initially, we are having, what is the applied frequency or used frequency? 1.5 times of nu naught. Okay. What will be the photoelectric current if the frequency is halved and intensity is doubled? Means the second situation or modified situation, what you are doing, frequency is halved, means what? Original frequency is 1.5 nu naught. Half means what? 1.5 nu naught by 2, which is equal to what? 0.75 nu naught. And let's say here the intensity is, here we will take the intensity is what? Some I. In this case, what are you doing to the intensity? We are doubling the intensity, means we are making the intensity as what? 2I. Then they are asking what will happen to the photoelectric current. See, why I said this is a theoretical question is, first of all, photo emission will happen when the applied frequency or the frequency of the incident radiation is more than the threshold frequency. Now in second situation, yes, we are doubling intensity. So intensity is quantified by what? Number of photons. Intensity is quantified by what? It is quantified by the number of photons. More intensity means what? More number of photons are incident. But what is happening to the frequency? Look at it. Frequency, if you halve the frequency means what? You are going below threshold. Threshold frequency is nu naught. You are going to, what is the frequency value in the second case? 0.75 times nu naught, means this frequency is less than the threshold frequency. Means what? In this case, the photoelectric emission will not at all happen, because photoelectric emission will happen when the applied frequency is more than the threshold frequency. So you are changing, you are doubling intensity, but the photocurrent is going to become what? 0. So photocurrent will begin when the applied frequency is more than the threshold frequency. Okay, so this is a question on the capacitor. Just a capacitor connected to the AC voltage. So here we will talk about the capacitive reactance. What is the capacitive reactance value? So we look at the question anyway. A 40 microfarad capacitor is connected to a 200 volt 50 hertz AC supply. Means, you know, we have the AC source. So 200 volt means what? This is the RMS voltage of the, because whenever they give the voltage of the source, that is representing what? RMS. Okay, so we are simply connecting a capacitor to it. And what is the frequency of that source, which is what? 50 hertz. What is the capacitance value? 40 microfarad. Now what they are asking, the RMS value of the current in circuit is nearly, means what they are asking, IRMS. See, IRMS will be equal to what? RMS voltage divided by XC. What is XC? Capacitive reactance. What is XC value? 1 by C into omega. Means finally what is the IRMS value going to be? ERMS by 1 by C into omega, which is what? C omega into ERMS. Okay. What is omega? Omega will be equal to what? 2 pi into the frequency. Frequency is given as what? 50 hertz. Frequency value is given as what? 50 hertz. Okay. So now we'll just go with the formula. What is it? IRMS is equal to what? C into omega into ERMS. Okay. C is what? 40 microfarad. Microfarad means 10 power minus 6 farad. We have to be careful about the units. Omega is what? Angular frequency is what? 2 pi into F. So F is 50, right? So 2 into pi into 50, which is what? 100 pi. Okay. And what is the ERMS value? 200 volt. Now what is it that we are trying to find? We are trying to find the IRMS, right? So what is it? We'll just have to substitute the values. So C is what? 40 into 10 power minus 6. Then omega is what? 100 pi. Everything is in the SI system of units. Okay. And ERMS is what? 200 volt. So substituting, what we are going to get? 200 is the ERMS value. Capacitance is what? 40 in 10 power minus 6 into 100 pi or 2 pi into 50. So if you simplify it, right, we are going to get the value approximately 2.5 amperes. Okay, so we can look at it. So this is what? 200 into 40, that is 8,000. Okay, 8,000 into 50, or rather we'll take it as what? 2 pi into 100 is, we'll take it as 50 is 100 pi. 2 pi into 50 is what? We'll take it as 100 pi. Okay, so this is 8,000 into 100 pi. This is 8 into 10 power 5 pi. Okay, so that's what we got. And there is one 10 power minus 6. So totally what we have? 8 pi into 10 power minus 1. Pi we'll take it as what? 3.14. So 8 into 3.14 into 10 power minus 1. In other words, what is it? 8 into 0.314. Okay, so 8 into 0.314 will be approximately 2.5. So what is the answer for this? It will be 2.5 amperes. Since everything is in the SI system of units, right, the current will be coming in what? The amperes. Okay, so here the only thing is, whenever any AC power supply, the voltage is given, means that represents what? The RMS voltage. Okay, and RMS voltage and RMS current are related. So what is the formula? IRMS is equal to what? Since it is a pure capacitor circuit, IRMS will be equal to what? ERMS by XC. Okay, so what is the answer for this? It is option 2. Next we will go to a question which is based on the limit of resolution. Assume that light of wavelength 600 nanometer is coming from a star. The limit of resolution of telescope whose objective has a diameter of 2 meters is. See, what is this limit of resolution concept? When you have the light coming from the object, if you have two distinct points on that object, okay, with a given angular separation theta, what is the closest proximity, or what is the smallest value of this theta, which can be resolved, in the sense, which can be forming two distinct images. So the images formed should be what? Distinct. And this particular angle is what we call as the limit of resolution. So limit of resolution for an objective lens of the telescope, right, will depend upon the diameter of that lens and the wavelength of the light. So here the formula is what? Delta theta, limit of resolution, will be equal to 1.22 times lambda by d. Okay, and lambda is what? The wavelength of the light, which is 600 nanometer, means what? Into 10 power minus 9 meter. Okay, and diameter is what? What is the diameter of the objective lens? It is 2 meter. D is equal to 2 meter. So all that we are going to do is just substitute in the formula. So from here what we are going to do, lambda is 600 into 10 power minus 9 meter, d is 2 meter, So what we are finding? Delta theta, the limit of resolution in terms of angle. Since we are taking the values in the respective quantities, the delta theta will be always coming in what units? Radians. Okay, so delta theta will be equal to what? 1.22 into lambda is what? 600 into 10 power minus 9 divided by 2. So if you simplify it, right, what we are going to get it? Look at it. So this is what? This is 2 ones are 2 threes. So 1.22 into 3 is what? This is 3.66. 100 in 10 power minus 7. It is what? 10 power minus 7. So what is the answer going to be? 3.66 into 10 power minus 7 radians. Option 4 is the correct answer. It's a straight formula question. Okay. So we just have to know what is the limit of resolution for a telescope. What is it? For the objective lens of the telescope, what is the limit of resolution value? It is what? 1.22 lambda by d. The limit of resolution in terms of radians. Next we have a question from the one-dimensional motion. This is the vertical straight line motion. A ball is thrown vertically downwards with a velocity of 20 meters per second from the top of a tower. So from the top of a tower we are throwing the ball with how much? 20 meters per second. That is the initial velocity. Okay. It hits the ground after some time with a velocity of 80 meters per second. Means when it is coming to the ground, finally, what is the velocity? It is 80 meters per second. Okay, it is hitting the ground. The height of the tower is, they are saying take the value of acceleration due to gravity is what? 10 meters per second square. Now it's a vertical straight line motion. We can also solve this question by using the work energy theorem, but we will do it by using the vertical straight line motion. Okay, so vertical straight line motion, when we are following it, right, we use a sign convention. Anything upwards is positive, downward is negative. So look at the initial velocity. What is it? 20 meters per second downwards, means what is it? Minus 20 meters per second. What is the final velocity? V? 80 meters per second downwards, means minus 80 meters per second. What is the acceleration? G? Acceleration is also what? Downwards, means what is it? Minus 10 meters per second square. And when it is coming down, say for example it is coming down by a height h, means displacement is also what? Downwards. So we have to take it as what? Minus h. Now what is the formula we have relating u, v, a and s? This is a uniform motion, right? Uniform acceleration motion. What is the formula? V square is equal to u square plus 2as. So v square minus u square by 2a, that is what is s. This is the formula. What is the formula? V square minus u square by 2a. So if you happen to practice some questions, means you will be able to remember all these things, and we can easily answer. Okay, so look at this. What are we having? We will have the formula to be used. What is it? V square minus u square by 2a is equal to s. V square is what? Minus 80 square minus 20 square divided by 2 into minus 10 is equal to minus h. Minus minus is cancelled. So from here what you will get? 80 square means what? That is 6400. Minus 20 square means what? 400. Divided by 20, that is equal to h. What is it? 6000 by 20, which is 300. The unit is going to be what? Since everything is in the SI system, the unit is going to be in terms of meters. So what is the answer? It is option 3, which is 300 meters. So if you remember this relation, right, in case of uniform acceleration motion, if you know the velocity, final value, initial value and acceleration, we can find the displacement. What is the formula? V square minus u square by 2a, that is the value of s. Okay, like that we will be able to easily answer, but the thing is sign convention. Okay, next we will go on to a question which is based on the gas properties. A cylinder contains hydrogen gas at a pressure of 249 kilopascals, means what? 249 into 10 power 3 pascals, and a temperature of 27, because you know whenever you use the gas laws, right, always the temperature has to be taken on the Kelvin scale. Means 27 degrees centigrade means approximately what is it? 300 Kelvin, because we have to add plus 273. What is its density? So they are asking us to find what is the density. What is the density formula? Rho is equal to what? Pm by RT. This is the formula for the density, right? Density will be equal to what? Rho will be Pm by RT. How do you get it? We will get it from the ideal gas equation. Okay, I'm not going to derive it. Maybe if you want, you can just derive it by using this relation. PV is equal to nRT. N means what? Mass of the gas by capital M, molar mass of the gas. That is PV. Now we will bring the volume this side, take everything to the other side. Mass by volume is equal to what? P into M by R into T. The R into T will go to the denominator. Mass by volume is what? Density, right? So rho is equal to what? PM by RT. Okay, so this formula we will be remembering. The density formula for an ideal gas. Density will be equal to what? P, pressure, into capital M is what? Molar mass of the gas. Capital M is what? Molar mass of the gas. Okay, so here we will just have to go and substitute. Now before we do that, right? So here what is the molar mass of the gas? It's a hydrogen. Means molar mass is what? 2 grams. But we have to take it in the SI system, right? Means what is it? 2 into 10 power minus 3 kgs. So look at it. Pressure is what? 249 into 10 power 3. We are taking everything in the SI system. Okay, into molar mass is what? 2 into 10 power minus 3 divided by R. What is the R value? 8.3 into temperature is what? 300. So this is cancelled. And by the way, the value of density is going to come in which unit? It is going to come in terms of the kg per meter cube, because everything we have taken in the SI system of unit. Okay, now look at it. What we have? 249 into 2. 249 into 2 is what? It will be 498. Okay, so 498 divided by what is there in the denominator? The denominator is what? 24.9 into 100. 8.3 into 3 is what? 24.9 into 100 is there. Okay, so look at it. What is it? 24.9 once, 24.9 20s. Okay, now 20 by 100 means what? It is 0.2. So 0.2 kg per meter cube. So what is the answer? It is option A. So what is the answer for this? It is option A. Okay, so I'll just erase some part of it so that you can see the result. Okay, so what is the answer for this going to be? It will be option A. 0.2 kg per meter cube. So it's a straight formula, right? Formula based question. We got the density formula. From the density formula, we'll just have to substitute all the given quantities. The only thing is we have to be careful about the units, especially where people usually make mistake is this molar mass. Because molar mass, we know it is 2 grams. If you straight away take it 2 right, then we will get a wrong answer. We should be converting this into the SI unit. That is what we have to be taking care of. And of course, one more thing where we can possibly go wrong is this hydrogen. Hydrogen, we should not take molar mass as 1 gram. We should always take it as what? 2 grams. Why? Because hydrogen molecule contains 2 hydrogen atoms. Okay, similarly in some questions, right, if you have a question on say nitrogen molecule, means we'll have 2 nitrogen atoms. Oxygen molecule means 2 oxygen atoms, like that. We have to be careful about those things. Next we have a question on the radioactive phenomena. This is a question where we will relate the atomic number and mass number. So when you have a nuclear radioactive phenomena, the atomic number and mass number of species on either side will be related. This is a question based on that. Look at it. When a uranium isotope U-23592 is bombarded with a neutron, it generates krypton 8936, means mass number 89, atomic number 36, comma 3 neutrons, and means there is one more particle that is getting generated. They are asking what is that another particle. So what we are going to do, we will just look at it. So uranium 23592, okay, and neutron. Neutron means what? The mass number will be 1, atomic number is 0. Proton means mass number 1, atomic number 1. Electron means atomic number -1, mass number 0. Okay. Positron means atomic number +1, mass number 0. This is positron. This is what? Electron. So these things, this is what? Proton. This is the proton. Okay. So these things we have to be comfortable in terms of using these mass number and atomic number of the respective species. Because if you make a mistake in that, means we will get the entire question wrong. These questions are easy only, but the only thing is we have to be careful about these numbers. So look at it on the we don't want to call it as a reactant and product, but we can call them as what? Original species and the final species. Original species, on the original species side, what we have? Uranium and 1 neutron. On the final species side, what are we having? Krypton 8936, 3 neutrons. And another species, what are we calling it as? Some X. We are in the search of finding what is this X. X has got a mass number A, which is the general symbol for the mass number, and atomic number Z, which is the general symbol for the atomic number. Now what we are going to do, the law. What is the law? If you have any radioactive phenomena, the total mass number count on the LHS side is equal to total mass number on the RHS. Total atomic number on the LHS is equal to total atomic number on the RHS, which means what? If you look at the mass number part, okay, we will have what is the relation? We'll have 235. We look at the first mass number. So mass number side, what is it? Original particles 235 plus 1 is equal to 89. Here we have 3 neutrons, so it will be 3 into 1 is 3 plus A. So from here A will be coming as what? 144. And on the atomic number side, what is the atomic number? Here we have 92 plus 0. Why 0? Neutron atomic number is 0. On the final species side, what we are having? 36 is the atomic number of krypton. Neutrons, they will not have any atomic number. Atomic number of the unknown species is what? Z. So Z will be coming as what? 56. So what is the species? It is having atomic number 56, and what is the mass number? 144. Now the thing is, in the options, if you see, right, they are even mentioning what is that element, but it doesn't matter. So whether, if you don't know what is the element, then it is not going to take away the mark from you, because they would mention the element name also, but we can answer the questions by just knowing these two numbers. So we'll have to check for where is our mass number 144. Check it, where is our mass number 144? It is coming only in one option. And sometimes when you are solving in the final examination, if you are able to come to this stage, like you are able to get mass number 144, you see only one option is satisfying it, you can just tick it and then proceed. Why? Because we don't need to solve for the atomic number itself. That is going to save some time for us, isn't it? Next we have a question on the PN junction diode. The increase in width of the depletion region in a PN junction diode is due to. So what is this depletion zone or depletion region whenever a PN junction diode is formed, right? So we have the P side and we have the N side. P side, what we'll have? The majority will be holes, and N side majority will be electrons. We will see that the moment the PN junction is formed, the electrons, because they are in higher concentration on N side, they will start migrating towards the P side, and the holes will start migrating towards the N side. So as a result, what we will be able to see is that on P side we will have a accumulation of these negative charges, N side will have the accumulation of the positive charge, and this would create a potential barrier. You can see this side it is a higher potential, this side it is a lower potential. This would prevent, so what the depletion zone will do, this would prevent, because otherwise all the electrons from N side should move out to the other side, right? Similarly, all the holes should move out to the N side. That is not going to happen. The depletion zone that is formed is going to prevent the further movement of the charges. We call it as the barrier potential. So what do you call it as? Barrier potential. So what is this barrier potential? Once this potential is formed, imagine, it will prevent, so you have a negative charge here, right? It will prevent further movement of electrons to the P side. Similarly, you have a positive charge here, it will prevent the further movement of the holes to the N side. So barrier potential will be able to prevent the continuous movement of the electrons from N side to P side and holes from P side to N side. So this is the role of the barrier potential. So every PN junction barrier, it will have a characteristic depletion layer, which will be, of course, very small in terms of the thickness. But this potential that is developed across the depletion layer is what we call as the barrier potential. Okay, barrier potential and the applied potential, right? The relation between them, the relation between the barrier potential and applied potential. Applied potential means when we connect the diode to any source, The potential of the source is what we call as applied potential. There will be some interesting relation between these two. We'll talk about it when we are analyzing the forward biased and reverse biased in detail. But here we just need to comment on when the width of the depletion region will actually increase. So here you have two possibilities. One is you connect the P side to the positive terminal. This is what we call as the forward biased. Other is you connect the N or negative side to the P. Accordingly, the positive side will be connected to N. In forward biased, positive terminal of the battery is connected to P. Negative terminal of the battery is connected to N. In reverse biased, what we see, negative terminal is connected to the P side, positive terminal is connected to the N side. That is what is the reverse biased. Now what is observed is, we will discuss about the reason. What is observed is, when any PN junction diode is forward biased, then as you can see in this depiction, the width of that particular depletion zone is actually getting reduced. Reverse bias means you can see the width is what increasing. This is what is observed. Now look at the reason for that. So what will be the reason for that? If we are doing forward biased, imagine. So what is there on the P side? All positive charges. What is there on the N side? All negative, majority. Now positive terminal of the battery is connected to the P side, means what? These positive charges will be repelled away, means they will be pushed to the other side. See, here you have a depletion zone up to this much, imagine. Now these positive charges are pushed away, so they will go and occupy, means there will be what? The charge nullification. Similarly here also, if you previously, let us say the positive charge is up to here, the negative terminal of the battery will push away the electrons, means the electrons will start moving this side. As a result, what is going to happen? They will occupy the positions of the previously positive places, means there will be nullification. So some amount of the depletion zone will be actually what? Nullified in terms of the charge, because the positive terminal will repel the P side holes, negative terminal will repel the N side electrons. That is the reason why we see that the depletion zone is actually what? Decreasing in terms of thickness. Now look at this story. If you are reverse biasing, negative terminal is connected to the P side. P side, what you will have? Positive charges, right? So these positive charges will be attracted, rather, means they would move towards the other side. Previously in the forward bias, they move towards the depletion zone. Now they are moving away from depletion zone. So what happens is, when the positive charge moves away from depletion zone, here also additionally you will see, because when the positive charge is moving away, means what? Additionally you will create some more. If the positives are moving away, means what? There will be some negative charge. Similarly here, the positive terminal is connected to what? The N side. Now the electrons will be attracted, so they will be moving away from the depletion zone. So as a result, here also you will see, because the electrons are moving away, means here we will see some net accumulation of the positive charge. So as a result, what we will see is there will be an increase in the thickness of the depletion zone. So this is the mechanism that is going to happen, which will result in the decrease of thickness zone in the forward biased and increase of depletion zone in the reverse biased. So when the width of the depletion zone will be increasing, it is going to increase only when it is reverse biased. Forward bias means it will be decreasing. Okay. Next we have another question which is sort of based on the simple harmonic motion. The phase difference between displacement acceleration of a particle in simple harmonic motion is. So for this, what we'll do is we'll take the standard equation of a particle in SHM. X is equal to a, let us say, sine omega t. Like that we'll take. So you take a derivative, it will give us what? The velocity. Velocity will be what? A omega cos omega t. Okay. So we take a derivative of the velocity. That will be giving us what? Acceleration only, no? So what is it going to be? A omega into derivative of cos omega t. So what is derivative of cos omega t? Minus omega sin omega t. So minus a omega square into sin omega t. So look at this. Acceleration can be written as what? Here don't confuse between the a and the acceleration, because so we'll rather clearly say it is acceleration, like that. Okay. So acceleration will be equal to what? A omega square. So minus A omega square sin omega t is there. Okay, so we can write it as what? A omega square into sin pi plus omega t. Okay, so if you want to write it in terms of sine function, how we can write it? We can write it as what? Sin pi plus omega t. What is the displacement function we have taken? X is equal to A sin omega t. Now compare both these trigonometric forms. Sin omega t. Here what is the phase? Omega t. Here what is the phase? Pi plus omega t. So the phase difference between the acceleration and the displacement will be equal to what? Pi plus omega t minus omega t. What is it going to be? Pi. So what are we doing? If you remember the standard equation of the displacement, we'll take it as what? X is equal to A sin omega t or X is equal to A cos omega t. Take that, do the first time derivative, we'll get the velocity function. Second time derivative, we'll get acceleration. Now acceleration, it is coming as what? Minus A omega square sin omega t. So we are trying to convert this into just the sine form. So sine of pi plus theta is what? Minus sine theta. Sine of pi plus theta is what? Minus sine theta. So we are writing minus sine omega t as what? Sine of pi plus omega t. So when we compare the phase angles, right, here what is the phase angle? Omega t. Here what is the phase angle? Pi plus omega t. So phase difference means what? Pi plus omega t minus omega t. That will be giving us what? Pi. So what is the phase difference between the acceleration and the displacement functions? In a simple harmonic motion, it will be what? Pi. Next, look at this one. An iron rod susceptibility, chi m, magnetic susceptibility, is 599. Is subjected to a magnetizing field of 1200 ampere per meter. This is the magnetizing field value. The permeability of the material of the rod is, means we have to find what is the mu for the material of the rod. See how susceptibility will be related. Look at this. Mu r, relative permeability, will be what? 1 plus chi m. Means 1 plus 599, which is 600. That is the mu r value. What is mu value? Mu is equal to what? Mu r into mu naught, right? Permeability of any medium is equal to what? Relative permeability into permeability of the vacuum or free space, mu naught. Okay. So now what we'll have? This mu r is 600. 600 into what is the mu naught value? 4 pi into 10 power minus 7. Just we have to substitute. So what you are going to get? 600 into 4 pi into 10 power minus 7. So here if you look at these options, right, they are not simplifying the pi, they are keeping it as it is. So 600 into 4 is what? 2400 into pi 10 power minus 7. So this is what, if you adjust the decimals, means 2.4 pi into 10 power minus 4. 2.4 pi into 10 power minus 4. Okay. So the unit will be what? SI unit. What is the SI unit? Tesla meter per ampere. Okay. So the answer is what? 2.4 pi into 10 power minus 4 Tesla meter per ampere. Option 4 is the correct answer. See, in these kind of questions, right, the only thing is we have to be a little bit careful about these exponential numbers, and whenever you are doing the adjustment of the decimal place, etc., right, we have to be little bit careful. Next, the quantities of heat required to raise temperature of two solid spheres, copper, radius R1 and R2, through 1 Kelvin are in the ratio. Means we have to find what is the delta Q ratio. See, for any object or material, like delta Q will be equal to what? M into S into delta T. Delta T is same for both of the 1 Kelvin. S is also same because both are copper. Where the difference is going to come? The difference will be coming in terms of the mass, because they both have different radii, right? What will be the mass formula? Mass will be equal to what? The density into volume. If you take the copper spheres, right, what is the volume formula? 4 by 3 pi r cube. So mass will be equal to what? Rho into 4 by 3 pi r cube, where rho represents the density of the copper. So we need to find what? The ratio of the heat that is required. So look at it. So what is the formula for the heat required? From the calorimetry principles, del Q, that is the heat required, is equal to what? Ms delta T. And in place of mass, what we are writing? The volume into density. 4 by 3 pi r cube into rho into specific heat is S, temperature change is what? Delta T. Both of them are having the same S value because they both are made up of copper. both of them are also going to have the same delta T. Okay, rho is also same because both are the same material. Now look at it. What does it mean? Delta Q1 by delta Q, that ratio, right, will be equal to what? Everything else is same. So if you take a ratio, right, delta Q1 by delta Q2, it will be equal to what? 4 by 3 pi R1 cube rho into S into delta T divided by 4 by 3 pi R2 cube rho into S into delta T. So everything this will be getting cancelled. What we'll have? R1 by R2 the whole cube. That's it. But what is the R1 by R2 ratio? R1 is equal to 1.5 R2, means R1 by R2 is equal to 1.5, in other words 3 by 2. Okay, so R1 by R2 is what? 1.5, which means 3 by 2 the cube. What is 3 by 2 the cube means? It will be 3 cube is what? 27, divided by 2 cube is what? 8. So the quantities of the heat required for raising the temperatures of these copper spheres through 1 Kelvin, what will be the ratio of these heats required? 27:1. Okay, so here the thing is what? We have to see that how we will relate the mass of that sphere to the radius. Of course, just pretty common thing whenever we want to relate the mass to the radius of the sphere. What is it that we'll think about? How we will get the mass as volume into density, isn't it? So what is the answer for this one? Option 4 is the answer. We'll move on to the next one. This is a connected mass system, pulley, across a pulley. Okay, two bodies of masses 4 kg and 6 kgs are tied to the ends of a massless string. So the string is what? Massless. In fact, these are the common assumptions we make. The pulley also we will consider to be what? Massless pulley. Okay, the string passes over the pulley which is frictionless. So friction here is what? 0. The acceleration of the system in terms of acceleration due to gravity. See, since these two masses are connected, which is the heavier one? 6 kg is the heavier one. So what we would observe is 6 kg will go down, let us say with an acceleration value A. Then 4 kg is going to go up. Why? Because look at it, they are connected, right? If the 6 kg is going down means 4 kg has to go up. Not only that, since the assumptions we make are the string is inextensible. Whatever the acceleration of the 6 kg means, let us say 6 kg is going down with the acceleration A. 4 kg will be going up with the same value of acceleration. And this acceleration is what you call as the acceleration of the system. So whenever they say a question like this, right, what they are essentially talking about, that A value they are asking us to find. Now what we will do is straight away, right, we will look at the 4 kg object. So it will be experiencing the gravity 4g connected to the rope. So there will be a tension will be always acting into the rope. Because of these two, the 4 kg is moving up with an acceleration A. Means what will be the equation? Net upward force. Upward force means what? Tension is upward, weight is downwards. Net upward force means what? Tension minus weight is equal to what? Mass of that object, which is 4 into the acceleration. Equation 1. Now we look at the other side, the 6 kg. It is having its own weight 6g. Of course, on the 6 kg also there is a tension acting. Tension will be into the rope. Because of these two, the 6 kg is going down with the acceleration A. Means the equation here will be what? Net downward force. Means downward force minus upward force. Net downward force is equal to what? 6A. These are the two equations. Now when we add both of them, right, here we have to find what? Acceleration. Add both of them. T and minus T is cancelled. So LHS what we have? 6g minus 4g is equal to RHS what you have? 6a plus 4a. So totally what is on the LHS? 2g is equal to 10a. Thereby a is equal to what? 2g by 10, which is what? G by 5. So what is the answer for this? Option 2 will be the answer. Okay. So here we'll sometime remember the standard result also. That is if you have two masses M1 and M2 which are hanging across a pulley, under the assumptions that the rope is inextensible and the pulley is frictionless, what we'll have is, on the string is massless as well as the pulley is also massless. If you have a system like this, right, we have a M1 here and M2 here. So this is the standard result that people remember. That acceleration of the system, we are calling it, right, will be equal to M2 minus M1 by M2 plus M1 into G, where we will take M2 as what? Higher than M1. M2 will be the higher mass and M1 is the lower mass. Okay, higher mass will be going down, lower mass will be going up. We can check. So here M2 is what? 6. 6 minus M1 is what? 4. 6 minus 4 by 6 plus 4 into G. 6 minus 4 is what? 2. Divide by 10 into G, which is G by 5. We will be able to get the answer. Okay. So if you don't remember this result, means we can again go and look at the equations for each of the blocks separately using the free body diagram. So what is the method that we have taken? The free body diagram method, right? We can do that way. Otherwise, if you remember the result, means we can straight away use that result and get the answer. Next, we have a theoretical question from the states of matter chapter. The mean free path of a gas with molecular diameter d and the number density n can be expressed as. So this is a formula for what? The mean free path. What is mean free path means? If you have a molecule from one collision to another collision, it will be traveling in a straight line. So what will be the path? It will be traveling in a straight line with a constant speed. Okay, that is what we'll have. After the collision, it might change its direction of motion and also the speed. So mean free path is the average value of distance between, what is it? The average value of distance between successive collisions. Okay, so that value, I mean, the derivation of the result is something that we are not going to anyway look at in the solution. We'll just look at the formula. This is a formula that we'll have in most of the textbooks, including the NCERT textbook also. We have this formula. What is the mean free path formula? It will be what? 1 by root 2 n into pi into b square. So the thing is, if the number density is increasing, then the mean free path, generally, we'll represent this with the symbol lambda. Lambda will be decreasing. Similarly, if the diameter is increasing, again the mean free path will be what? Decreasing. Means mean free path will be more when you have smaller molecules with a lesser number density. That is when the mean free path will be more. Okay, so the answer is what? Option 1. Next, we have a question on the electric potential developed by a short dipole. What is it? Electric potential developed by a short dipole. So what is it? A short electric dipole has a dipole moment. P value is given. What is it? 16 into 10 power minus 9 coulomb into meter. The electric potential due to the dipole at a point distance of 0.6 meter from the center of the dipole, situated on a line making an angle of 60 degrees to the dipole axis. What do you mean by the dipole axis? Think about it. If you have a negative charge, you have a positive charge. Okay, so the dipole moment will be from which direction? Which direction? From the negative charge to positive charge. This is the center. You have a point which is at a distance r. This is the point P. Okay, this is the point. Okay, the point is making an angle theta with the dipole axis, means we are considering the direction of the dipole moment. This is theta. So if the dipole is a short dipole, right, we have the formula for the electric potential at that particular point. What is the formula? K into P into cos theta by r square. What is K? Coulomb's constant. Okay, and what is the value of Coulomb's constant? Here it is given as what? 9 into 10 power 9, which is what we'll also generally remember. Okay, sometimes if they particularly give us the value of constant, ask us to take it. Like generally when we are solving the problems on say for example the Planck's constant, we'll take it as what? 6.626 into 10 power minus 34 joule into second. But if in a particular question they are saying take it as 6.6, then definitely we have to take it as 6.6, because while they are framing the question, they would have made some adjustment in terms of the numerical values. But here what we generally remember is also what they have given. Okay, so what is the formula for electric potential due to a short dipole? Kp cos theta by r square. K is what? 9 into 10 power 9. Okay, and P value is what? Everything in the SI system. So the voltage will be coming in volt. So P is what? 16 into 10 power minus 9 coulomb into meter into cos theta. What is the angle here? Theta is what? 60, right? So cos 60. What is cos 60? Half. Divide by r square. What is the r value? 0.6. R square means 0.6 into 0.6. What is it? 0.36. What is the value? 0.36. Okay, now we'll just have to do the simplification. So 10 power 9, 10 power minus, so what is it? 9 ones are 9 into 0.04. Then what we will be having is 16 into half by 0.04. So 2 ones are 2 8s are. So if you multiply both numerator and denominator by 100, what is it? 800 by 4, which is equal to what? 200. So what is the voltage value going to come? 200 volt. So at a point which is the distance of 0.6 meter from the center, making an angle of 60 with the dipole axis, what will be the electric potential to the short dipole? It is 200 volt. Then this question is given as an example in various analysis to indicate that okay, the NEEt 2020 paper is probably one of the easiest of the paper and things like that, because this is one question that we'll see very often, isn't it? While we are practicing for the dimensional formula, right, we keep looking at some common quantities, and what is it? We have to find the dimensional formula for stress. Dimensional formula for stress will be same as what? Pressure. And what is it? It will be what? Force by area. So stress formula is what? Force by area, right? Force is what? ml t power minus 2 divided by area is what? L square. So what is the formula? ml power minus 1 t power minus 2. This is same as the dimensional formula for the pressure also. So what is the answer for this? It is option 3. Next we have another such question. This is just about energy conversion. That's it, nothing more. Okay, the energy required to break one bond in a DNA is what? 10 power minus 20 joules. What is the energy required? Energy in joule. What is the value? 10 power minus 20. This value in electron volt is nearly. So remember, energy in electron volt will be what? Energy in joule divided by 1.6 into 10 power minus 19. That's it. So what is it? 10 power. So 10 power minus 1 will remain in the numerator by 1.6, which is what? Which is like if you bring the 10 power minus 1 means 1 by 10, right? So this is what? You will get a 10 in the denominator. So 1 by 16. What is 1 by 16? It will be approximately 0.06. It's a straight conversion. You want to convert energy from joule into electron volt means divide by conversion factor. What is the conversion factor? 1.6 into 10 power minus 19. Okay, if you want to convert the electron volt value into joules, then what you have to do? You have to multiply by same factor. So what is it? Energy in, so this is not about this question, but I am just saying conversion. Energy in joule will be equal to what? Energy in electron volt multiplied by, this is the conversion factor.